we are going to find the differential of this. So basically, we're going to find the derivative. And I'm going to write dy dx instead of y prime. So dy dx, I'm going to rewrite this one as 9 minus x squared to the 1/2. It's easier to derive it then. Bring the 1/2 out front when you derive it. It's a chain rule. 9 minus x squared. Put negative 1/2. And then don't we derive the inside? Derivative of the inside looks like positive 2x. Now, actually, you're right. Negative 2x. Okay. That's my derivative. My differential is simply, you take this derivative and you multiply the dx over. So you end up with dy, you multiply both sides by dx. Okay, when you multiply both sides by dx, that cancels. And you end up with, let's see, if we simplify this, isn't that going to be x over, aren't these 2's going to cancel? So that'd be negative x over 9 minus x squared to the 1/2 dx. That would be your answer. That is a differential. The change in y is equal to this equation, change in x. That's how you say it. All right. This problem right here. You have a base of 30. So you measured this as 30, not drawn to scale, that's 50. Now, if you have a triangle, you measure it, you're not going to be perfectly accurate. You say to yourself, I can measure within 0.25 or 1/4 of a centimeter accuracy. You kind of give yourself an amount of error in your measurement. That's how accurate you think you are. Plus or minus, you understand this plus or minus? You can be above and below by 0.25. You think you're that accurate. Everybody might be differently, or you're computerized, if you're doing computer-wise, it has a certain amount of accuracy. The question is, what is the propagated error of the area? So what would be the area? Well, the technical area would just be 30 times 50, right? Divide by 2. Because it's a triangle. But with this situation, we're going to see what the error would be off by. So area is equal to 1/2 base times height, correct? Now, if I wanted to do this, I wanted to find my propagated error that's off by. What I want to do is I want to derive my area by either base or height. It doesn't really matter which one. So if I derive my area in terms of base or height, so this is going to be dA over dH is equal to, do you see a product rule? Can I put 1/2 just out front? What's the derivative of B in terms of H? Wouldn't that be dB dH times H? Plus, if I leave B and I derive H, wouldn't that be dH dH? We just derived in respects to either H or D. It didn't H or B. I chose a letter. Now, dH dH. What does dH dH equal? dH dH is equal to 1, correct? So won't that just kind of drop out? Now for differential purposes, I'm going to multiply both sides by dH. So I now have dA is equal to 1/2. Now, would I distribute this? Is that okay? And when I distribute here, don't the DH's cancel, leaving me just dB? Oh, sorry. Can I put the H first? H times dB. Are you guys okay with that? This DH comes in here, and it's going to cancel with this DH. And this comes in here. Won't that just give you B DH? Looking back, I should have probably showed you, but I'm multiplying this in. It's going to cancel with this, leaving you just H dB, and this is B DH. Okay. Now, I want to know my propagated error. This is my change of A. What are my possible changes in A due to my possible changes in the B and the possible changes in the H? Are we okay? Now, so dA is equal to, what's the height I measured? 50. Now, dB we don't know yet, but I'll talk about that. Do we know B? B is 30, but I don't know DH yet. Remember back up here? Isn't that my measurement, my possible mistake on my measurements? Now, would both these be affected the same amount? For this particular problem, are you guys okay that DH equals dB? Do you understand those are the same? Because the amount of change of my height and the amount of change of my base, should those be the same if I'm the one measuring it? And I have my little measuring tape and I know I'm off by a blank amount, won't those be the same amount? And won't the change be plus or minus 0.25? Are you okay with that? For both of them, it could be off positive 0.25 or less positive 0.25, or less 0.25. So are you okay that I put in here positive or negative 0.25 for both of these? You guys okay with that? My dB, my DH, my change in H, height and base, could both be off by 1/4 centimeter. When I do this, I end up, could I pull a GCF out? My dA is going to be plus or minus 0.25 over 2, and what's 50 plus 30? 80. When you solve that, you end up with positive or negative 10.75 centimeters. Now, your area, centimeters squared, because aren't you doing area? Now, what this means is my area could be off by 10.75 square centimeters. What is my area? My area was 1,500, correct? But my area it's 1,700 is my area, right? But it could be off by 10.25 plus or minus due to the errors on my measurements. The change in A could be this much. Okay, let's do another one. I measured a circle's circumference. Circumference is 56. I know a possible error of 1.2 in my measuring, especially circumference. Do you see how there's a lot bigger discrepancy? Circumference is kind of hard to measure. So, I want to, though, find my percent error. Is there a difference between percent error and propagated error? Percent error is just, you'll see, it's propagated error made into a percent. You'll see. So, I have my circumference. I measured my circumference, right? But what are we trying to find? Propagate error of area. So my formula, where do we want to find percent error of my area? So this is my formula, pi r squared. Isn't that what I'm going to be deriving? But do we have anything with a radius in here? Aren't we finding the error of my area? But we have nothing dealing with area. What do we have? Don't we have circumference? Isn't What is circumference? If you didn't know, it's 2 pi r. Do I know my circumference? Yeah, aren't we dealing with circumference? Could I go and change this equation to have a c instead of an r? Because aren't we dealing with circumferences? Isn't this measurement in circumference length, not in radius length? So, basically we need to, for this equation, we need to solve this for r. So you got r equals c over 2 pi, and then we're going to come and stick this right there. So my equation looks like it's going to be c squared and over 4 pi. Does that look right?
Yeah.
Pi squared?
Yeah.
No, because the pi is going to cancel with that pi. Pi is going to cancel with that pi. So that's my formula. Are we going to derive that? Yes. So the derivative of this is going to be dA, and what are we deriving by? C, correct? Isn't everything in terms of circumference? And isn't that a C there? So what's the derivative? Oh, can I just put 1? Can I bring that out? Is that a constant? 1 over 4 pi? So isn't that just c squared? What's the derivative of c squared? 2c. Is that okay? Isn't there really a dc? But I don't need that because that's 1. Now, can I multiply both sides by dc? And I now have dA equals c over 2 pi dc. What are we trying to find? The percent error. So don't we need the propagated error first? The amount of error off. I want this. Do I know C? Yeah. But what's this 1.2? Is that DC? Isn't that the possible error, the change of my circumference? Is that correct? So wouldn't dA be equal to 56 for circumference over 2 pi, and isn't my change on circumference going to be plus or minus 1.2? So your dA ends up being, I'll just give you that funky looking number. That funky looking number ends up being plus or minus 33.6 pi. That's your possible error discrepancy. It's your possible error discrepancy. Now, that's your propagated error. I want my percent error. What's the area of this if it was accurately drawn? Wasn't that circumference 56? Could I go back to this formula and plug in my actual circumference and find what the area should be? Go in here. If I plug in the 56 to this, do I get an area of 56 squared? Oops, that's not supposed to be there. Over 4 pi. Are you guys okay with that? Is that the area we should have? So wouldn't the percent error be this divided by the actual area it should be? You guys okay with that? Isn't that the propagated error? That's 33.6. I messed up. wouldn't the percent error be the amount it should be off, could be off, divided by the actual area it should be? Would that be your percent error? And it ends up being 4.286% off. If you take what the area should be, okay, divided by what it should be, divided by how much off you could be, that little bit amount off out of the whole area, it is a 4.3% off of your area. So your area could be off by about 4.3%.